Good morning and welcome back to the structure of atoms. Now today we will see line spectrum of hydrogen and Bohr theory and all. Slightly try to understand more careful because it is not easy subject. Some 2-3 classes. Okay. Now take a discharge tube. In that keep the hydrogen gas and when electrical discharge is passed through the hydrogen gas is bombarded with electrical discharge. Electrical discharge is passing through the hydrogen gas. It will become the hydrogen atom. Then excited hydrogen atom emits the radiation. That means all the time normally the sample will be irradiated with the light source, sometimes the white light or whatever it is, then it will be with a through slit. From slit it will come back to the one prism. In the prism it will be split. There is split will be taking place and then it will be recorded. That will be the normally the experiment for the absorption or emission. If it excited ray and all. So there will be some lines on the detector. That is called the spectrum lines of the hydrogen. First it was checked by the Balmer scientist. So he found the one line. So on his name that lines are called Balmer series or Balmer lines for hydrogen atom. What he has found, wave number is given some constant. It is a very big derivation and all these things. It is not there in for you or this thing. 109 677 into 1 by 2 square minus 1 by n square centimeter inverse, because it is a wave number, and where n equal to 3 or equal to 3 or more than 3, and where n is called integral or greater than Balmer. This is the Balmer series. The same experiments was continued by the Rydberg, and he found that not only the 1 by 2 square minus 1 by n square formula is varied, and he has given the same number 109 677. Instead of the 2 square he has given n1 square minus 1 by n2 square, where n1 is equal to 1 2 3 and n2 equal to n1 plus 1. So that is the, and this 109 677 he has called as a Rydberg constant. From this you will get so many lines. Remember, once again I am telling, sample is either excited by taking absorption, you can see the absorption lines, or the hydrogen gas when it is emitting the excited hydrogen gas, there will be series of lines, but you can found only Balmer series lies in the visible line, whereas the Lehman there and the Paschen is there, bracket is there, profound is there. There are so many other lines are there. Those are all ultraviolet and infrared lines, though that cannot be visible, that cannot be seen, but you can see the black lines and all in the spectrum. So that will be the, what is the meaning of this? Meaning of this is, you go back to again Bohr model. Now in detail we will tell the Bohr model. In the Bohr model, he has told it nucleus is at the center, that is the Rutherford itself is told, where neutrons and the protons are there, and the nucleus around that there will be fixed orbits, circular orbits. The electrons are revolving in the orbits. Whenever electron is jumping from the one state to the other state, means by absorption, means it is taking the electron is from here n1 to, it is going to the higher state, that is absorption. And so one more line is the one more line, like this you can circle as many as, till the electron is deviating away from the nucleus. That is called n equal to infinity. N equal to infinity means that is called the ionized atom, that is IP, ionization potential. If that much energy is there, there will not be any absorptions and all these things, and so it is detached from the nucleus. Whereas while coming back, it is giving the emitted radiations, coming back to the lowest energy state. So that is the difference all the time. Remember, Electron is taking the energy and going to the different states, and if energy is sufficient, it will detach from the ion, and it will be detached from the atom and it will become ion. So that is ionization potential. Now, interestingly, question will come: how much is the distance from the nucleus to the first orbital, second orbital, and all? And what is the energy levels of? Because energy levels he has told it is fixed. As long as it is rotating the particular orbit, there will not be any radiation at all, there will not be any absorption or the emission. Once this is taking the heating, then it will go to the higher states, and then only it will be emitting and all. So that is this thing. And here one more term we have to say. Normally we will say it is a normal velocity is called linear velocity. Whereas in the one circular motion, if it is there, it is the angular velocity. Angular velocity normally that will be represented by omega. That is nothing but omega is nothing but v by r, angular linear velocity by the radius of the circle. Then similarly, momentum is for the moment of inertia. Normally mass will be taken here. Moment of inertia represented by normally will be the I. Angular momentum equal to I into W, whereas I equal to moment of inertia. Moment of inertia is nothing but m r square, and this is v by r. If I am cancelling r, it will be m v r. Always take it as m equal to m electron, mass of the electron, and mvr normally will represent. This is the nothing but angular momentum. For a we are talking about the only hydrogen atom, because other atoms it is more complicated and all this, many other parameters also. So angular momentum for a hydrogen atom is equal to m electron for a mass of the electron plus the linear velocity and the radius of the this thing. Whereas we know that h by 2 pi into n equal to angular momentum, mvr equal to. Right. Now, if I want r, that implies r equal to n h by 2 pi into 1 by mv. This mv is nothing but the momentum, mass into velocity and r. So if you see all these things, n is only the variable, other things are they fixed almost for an electron. So now here n is called by Bohr as a principal quantum number. It represents the orbits 1, 2, 3 and orbit. If n equal to 1, it is the first orbit. And how from here he has calculated the radius of the first orbital. So r equal to after doing so much measures and all is n square into a0. Very interesting. If n equal to 1 first orbit, r equal to a0. This is called Bohr's orbital. This name is Bohr's orbit. Bohr's orbit. It is a fixed. That is a very big important this thing. Whereas a0 is nothing but 52.9 picometer. That means into 10 to the power of minus 12. Pico is minus 12 meter, or 5.29 into 10 to the power of minus 11 meter or centimeter, whatever you want. Whereas if n equal to 1, that is nothing but the Bohr orbit. That is the most important. Now, how much is the energy for the Bohr orbit? Bohr orbit means hydrogen atom, first orbital radius equal to, this is the radius, because n is equal to 1 only. So, 52.9 into 10 to the power of, this is the radius of the first orbit. Right. Now, how much is the energy? Energy E equal to minus RH, Rydberg constant, into 1 by n square. Rydberg, how much is the Rydberg value? Rydberg value everybody knows that we will keep that is 2.1 into 8 into 10 to the power minus 18. Y minus we will see. And n equal to, if 1, that equal to nothing but, this is the value for so many joules. That is the first orbit energy. Okay, always we will keep minus. What is y, what is minus, and what is the, because 0 is taken as a when atom as in the electron is in the free state, that energy is 0. when it is coming down to the nucleus, that means from the far distance, this is the ionization potential, from the here it is coming to the n equal to some 10, 20, 11, like that, then it is coming to the, from 0, sorry, it is 0, and it is coming to the nucleus, nearer to nucleus, then this is the first orbital or second orbital. This is the one which is a free is 0. So from 0 it is going back, so it is a negative represented normally. This Bohr theory can be extended to the helium ions and all other things also. Similarly, other line spectrums also, nothing but the energy you can find out for the differential energy and all by just using the same Rydberg constant, delta equal to 1 by RH into 1 by n1 square minus 1 by n2 square and all these things. Tomorrow we'll see further and all. Thank you.